Okay, let's do some homework problems from exercise 10A. Question 6 says, let's look at question 6. How many 3-digit numbers can be formed using the digits 2, 3, 4, 5, and 6? And then part A says, as often as desired. Okay, so we got 3 digits, 1, 2, 3. Okay, and then we have 1, 2, 3, 4, 5 numbers to choose from, and part A says we can use them as much as we like. So because there are 5 numbers to choose from for each of the positions, that means we have 5 choices to go in position number 1, and then for each of those 5 choices, we have 5 choices to go in position number 2, and then for each of those 5 choices, we have 5 choices to go in position number 3. So just as an example, we could choose the digit 2 to go in the first position, we could choose the digit 5 to go in the second position, and we could choose the digit 6 to go in the third position. So 2, 5, 6 would be a 3-digit number. By the way, just in case the word digit is new to you, so the digits, there are 10 of them, and these are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 digits in the base 10 number counting system. Those are what they are. And so 256 would be a 3-digit number. And of course 5 times 5 times 5 is 125. Let's move on to part B now. It says at most once. So we're still making a 3-digit number, but this time we can use each digit at most once. So we got 1, 2, 3 positions still for our digits, but this time we have 5 choices to go in position number 1. But then, I don't know, suppose we used 3. That means we only have 1, 2, 3, 4 choices for position number 2. So for each of the 5 choices for position number 1, there are 4 choices for position number 2. And then suppose we use 5 in the next one, that leaves us with 1, 2, 3 choices for position number 3. So that's 5 times 4 times 3 equals 60. Let's do question 7 now. It says, how many different alphanumeric, so alpha I guess is short for alphabet, and numeric means number. So alphabet, numeric, number plates for a motor car registration can be made if the first 3 places are English alphabet letters and the remaining 3 places are 3 digits from 0 to 9. There is nothing that says we can't repeat them. So you could have, for example, CCC 000. That would be legitimate, because I mean the purpose of a number plate is just to identify a car. So that would be a legit number plate. And by the way, in the English alphabet, there are 26 letters. 26 letters. And so the total number of choices for our positions, we have 26 choices for the first position. For each of those 26 choices, there are 26 choices for the second position, because we can put any letters we like in the first and second position, and the same with the third. So 26 times 26 times 26, and then for the 3 numbers, we have 10 digits in total. So 1 to 9, and then 0 makes 10 digits. 10 digits from 0 to 9. So that gives us 10 choices for the first digit, and then for each of those we have 10 choices for the second, and for each of those we have 10 choices for the third. So in total we have 26 cubed times 10 cubed, or 260 cubed I guess, and that gets us 17,576,000. Alright, moving along to question 8. It says, and let's do part A, it says, in how many ways can 2 postcards be mailed into 2 mailboxes? So let's let this be our set of postcards, postcard 1, postcard 2, and then we have 2 mailboxes. So how many ways can we put P1 and P2 into these 2 positions is basically what it's saying. Well, we have 2 choices for the first position. We could put P1 or P2 here. And then for each of those 2 choices, for example, if we put P2 there, there's only 1 choice for the second position. So the answer is just 2. For part B, this time it says, how many ways can 2 postcards be mailed into 3 mailboxes? So we got postcard 1, postcard 2, and then we got mailbox 1, mailbox 2, mailbox 3. Interesting. Well, the first thing we need to do is choose 2 of the post boxes. Now, in order to get 2 post boxes out of the 3 mailboxes, that's just the same as choosing one of the mailboxes that we don't put a postcard in. There's 3 ways to do that. So for example, if I choose this one here, that's not going to have a postcard in it. I could also choose this one here or this one here. So there's 3 possibilities, and then once I've chosen it, it's just an identical problem to the first one. So it's 3 times 2 times 1 equals 6. Interestingly, though, it might help to slightly reframe this problem, reframe the style of solving the problem anyway. So instead of looking at the postcards and pairing them with the 3 mailboxes using this image, let's instead consider the 3 mailboxes, mailbox 1, mailbox 2, mailbox 3, and then this time we're going to pair them with the 2 postcards. So postcard 1, postcard 2. And so we need, for each of the 2 postcards, we need to choose a mailbox that goes with it. And, well, there are 3 choices of mailbox for postcard 1, and then for each of those 3 choices, there are 2 choices of mailbox for postcard 2. And we see that we get the same answer. So it's 6. Alright, lastly, let's do question 8, part C. And then it says, how many ways can 4 postcards be mailed into 3 mailboxes? So for this one, let's write our set of postcards. Postcard 1, postcard 2, postcard 3, postcard 4. And then we have 3 mailboxes. Mailbox 1, mailbox 2, mailbox 3. Now for this one, we actually have to be a little bit careful. We have to choose 2 postcards to go into the same mailbox first. Okay, because we've only got 3 mailboxes. So that means this time we actually have to put 2 of them into the same box. And for now, we can just write it out. Later on in this unit, you're going to get way more efficient ways to do it. But for now, we're just going to count them out. We've got P1, P2, that's a choice of 2. P1, P3, P1, P4. And then we don't need to do P2, P1 again. So let's do P2, P3, P2, P4. And then the last one is going to be P3, P4. There's actually only 6 of them. So that gives us a total of 6 choices for our pair. So 6 choices of putting 2 postcards in the same mailbox. 6 different pairs that can be put into the same mailbox. And then once we've chosen that pair, we can just list out the others. So P3, P4, P2, P4, P2, P3, and then P1, P4, P1, P3, and P1, P2. And so now you can imagine that these 2 that are going into the same box, they're stuck together. So just think of them as a single postcard now. So now we actually only have 3 postcards to worry about in each of these 6 situations. And so for each of the 6 situations, there are now 3 postcards and 3 mailboxes. And so for this first postcard, I can put it into either any of these 3, the second one and the third one. But the point is, for the first mailbox, I can choose any one of these 3 postcards. So I could choose postcard 4, postcard 3, or postcards 1 and 2, which I'm now calling postcard 1. Okay, so that gives a total of 3 different choices for the first post box. And then for each of those 3 choices, suppose I chose this one, there are now 2 choices, either this one here or this one here, for the second box. And then suppose I chose that one, that just leaves 1 choice for the last box. So that gives us a total of 36 different ways to do this.